Hello students, so we'll continue with the questions. Question number 29. Okay, so here you have to prove the integration property. Okay, you have to prove that 0 to 2a fx dx. I'll write here, prove that okay, this we have to prove, and then you have to show that is by taking the f of 2a minus x equal to f of x and f of 2a minus x equal to minus f of x. Okay, so let's start proving this, starting with LHS. 0 to 2a fx dx, this can be written as 0 to a f of x dx plus a to 2a f of x dx. Okay, so we are writing the limits a to c as a to b and b to c. Okay. Now substituting here, that is in the second term of this, that is in place of x, that is we are taking 2a minus x as t. So our x will be equal to 2a minus t. Okay. Then when it is x is equal to a, we'll get t equal to a. And when x is equal to 0, not 0, x is equal to 2a, we'll get t equal to 0. So accordingly we have to change the limits. So our integral becomes, first integral you have to keep as it is. Here this becomes a to 0. Okay, also we have to take the derivative, that is dx will be minus dt. Okay, so substituting you will get 2a minus t minus dt. Okay, this remains same. This is minus sign we can take outside, so this a to 0 we can shift to 0 to a using the property. So this becomes plus. And then we can write in place of t x. Okay. So this is proved. This is our RHS. Now we'll prove the second part, which is, so you have to take when f of 2a minus x is f of x, okay, in this integral. So 0 to 2a fx dx, we have to substitute here. So f of 2a minus x, we have to write f of x. So this will be 2 times f of x. This is proved when it is this is minus x, then you will get 0 to a f of x dx, and the other term is minus. So this is 0. Okay, so this is proved. Next question is question number 30, that is using integration you have to find the area of the smaller region bounded by the ellipse. Ellipse is given and a straight line x by 4 plus y by 3 equal to 1. Let's write the equation. Question 30. So ellipse equation is x square by 16 plus y square by 9 equal to 1. Now we know that equation of the ellipse is written as x square upon a square plus y square upon b square equal to 1. So here our A, if I compare this with okay, so this is horizontal ellipse as A is bigger, right? It is our A is 4 and B is 3. So this ellipse will be of the form, this is 4, 3. Okay, now this is 0 comma 4 comma 0 and this is 3 comma 0. Okay, now the second thing which is given is equation of the line is given. So write it in a general form. So it will be 3x plus 4y and this will be 4 3s are 12, 12 into 1, so 12. Okay, if I plot this line, that is when you take x equal to 0, you will get y equal to 12 by 3, so 4, and when y equal to 0, you will get 12, no, x equal to 0, 12 by 4, you will get 3, and y equal to 0, you will get x equal to 4. Okay, so the same points you are getting, that is this is 0 comma 3, this I have written wrong, 0 comma 3 it is because y coordinate is 3, and this is 4 comma 0. So the line is passing through these 2 points, so this line is like this. Okay, so the area bounded by the smaller region we have to find. So we already have the points. Okay, so let's start. So the area, so I'll take both this equation in terms of y. So when you write ellipse equation in terms of y, you will get 1 minus x square upon 16 root of 1 by 3. Okay, so which you can write this is 9, 3, 3. So 16 also comes, this becomes 4, and this will be 16 minus x square. Okay, so this is ellipse, and for this line I can write y equal to 12 minus 3x upon 4. Okay, so the area, okay, I am taking, it changes from 0 to 4. Okay, so I'll be taking the dx element. So 3 by 4, 0 to 4, area of the ellipse, and this you have to subtract, that is area of the line. Okay, so this will be root of 16 minus x square dx minus, this is 1 by 4 0 to 4, 12 minus 3x dx. Okay, so using the formula, this is sin inverse x by 2 root of 16 minus x square plus a square by 2 sine inverse x by a, 0 to 4. Here you can take 3 common, so this will be 3 by 4. 3 4s are, so this is 4x minus x square by 2, 0 to 4. Okay, 3 by 4 from both these terms you can take common. So this is 4 by 2. 0 term will go, so the second term is not there. So for the first term, this is 4 by 2, this is 2 root of 16 minus x square. This also goes 4 square, so 16, 0. This is 0. Then this will be sine inverse of 1, right? So pi by 2. Then minus, when you substitute here 0, this term becomes 0, and sine inverse of 0 is 0. So that term goes. So only term remains is this. Then minus 4 4s are 16 minus 16 by 2, and when you put 0, these two terms goes, so only thing remains is this. 3 by 4, 4 pi, 16 minus 8 is 8, 8. So if I take this 4, so this will be 3 pi minus 12. This is the answer. This is 2's 3 to the 6, 6. So 3 pi minus 2 square units. Okay. Let's solve the OR question, that is using integration find the area of the smaller region enclosed between parabola. Okay, parabola is given. Equation of the parabola y square equal to 16x, and the line is given, which is x minus y plus 3 equal to 0. Okay, let's draw the parabola first. So this is y square equal to 4ax. This is 4 into 4x. Okay. Now we have to find the points which are common to both. So the x minus y plus 3 equal to 0. So you have to substitute this x or y in this equation. So I'll take y equal to x plus 3. Okay, substituting in equation 1, that is y square equal to 16x, x plus 3 square equal to 16x, x square plus 6x plus 9 equal to 16x, x square plus 6x minus 16 minus 10x plus 9. Okay, so this will be x minus 1, x minus 9. So x is equal to 1 and x is equal to 9. Okay, so these are the x points. If you want, you can find the y points. So for x equal to 1, you will get y equal to 4, and for x equal to 9 you'll get y equal to 12. Okay, let's plot this. So x is 1, y is 4. 1 2 3 4 1. So that this parabola should like this it is. Okay, x is 9, x is y is 12. 2 3 4 5 6 8 9 and 12. Somewhere here that line will no, not like this. You can find this line, you can draw. When you take x equal to 0 you will get y equal to 3, and when you get x equal to y equal to 0 you will get x equal to -3. So this is x is 0, y is 3, 1 2 3 this point, and when y is 0 x is equal to -3, 1 2 3 this point. So this passes like this, the line is like this. Okay, so it will be something like this. Okay. 9 and 12 it is, right? So somewhere here that point will be 9 and 12, and somewhere here it is the point 1 and 4. Okay, so this region you have to find. So we have the points. I'm taking x points. So we are changing with respect to dx. So we want y terms. So from parabola you will get y equal to root of 16x, which is 4 root x, and for this you will get y equal to x plus 3. So the area is given by integral. We are changing from x, so 1 to 9. First is our area of parabola, 4 root x dx, and we are subtracting that line, area below the line, right? So this is 1 to 9 x plus 3 dx. Okay, so this is 4 root x. Root x means x raised to half plus 1, 3 by 2. 3 by 2 upon 3 by 2, and this is 1 to 9 minus x square by 2 plus 3x 1 to 9. So this is 4 into 2 by 3. 9 raised to 3 by 2 minus 1 raised to 3 by 2 minus 9 square 81 by 2 plus 27 minus half plus 3. Okay, so this will be 8 by 3. This you can write it as 9 raised to half. 9 raised to 3 by 2, you can write it as 9 raised to half into 3. So 9 raised to half is 3, so 3 cube. that is 27, minus 1 minus 81 by 2 minus half, so 80 by 2, plus 27 minus 3, 24. Okay, so this is 40. 8 by 3 into 26 minus 40 minus 24. So this is this remains same. Six 64. By 3. So this is 6 1 0. 16 by 3 square units. Okay.